All right, today we are opening up a case file on some of the world's most effective and frankly most overlooked killers. We're talking about creatures so small you'd probably just swat them away without a second thought. But these tiny creatures are responsible for more human deaths than any other animal on the entire planet. So forget the big predators you think you know, we're going hunting for the tiniest serial killers.
So let me just ask you, straight up, what do you think is the world's deadliest animal? Just take a second. Let an image pop into your head. What's the first thing that comes to mind?
Now, if your mind immediately went to something with giant teeth, maybe a shark, or a lion, or even a venomous snake, well, you're in good company, but you're also way off. I mean, sure, those animals are definitely dangerous, but their body count, it doesn't even come close to our main suspect. The real killer is so much smaller.
And the answer is all wrapped up in this one really important word, vector. A vector, as you can see, is basically a delivery service for disease. It's an organism that picks up a parasite or a virus from one animal and drops it off in another. And the most prolific, the most successful, the deadliest vector on Earth is the mosquito. They, along with a whole crew of other tiny arthropods, are the assassins we're investigating today.
So let's get this investigation started. First up, we're unveiling the suspects. We're diving deep into vector-borne diseases, illnesses that are spread by this huge group of insects and their relatives. And believe me, their impact on human history is just staggering.
Topping our most wanted list without a shadow of a doubt is public enemy number 1, the mosquito. I mean, this one type of insect is basically a master criminal responsible for spreading some of the absolute worst diseases we've ever known. Let's take a closer look at its rap sheet.
You know, mosquito isn't just one single bad guy. It's more like a whole crime family, and they've all got their own specializations. You've got the 80s crew, infamous for spreading stuff like dengue and Zika. Then there's Anopheles. This is the one that transmits malaria, a disease that even today infects over 200 million people every single year. And we can't forget Culex, bringing diseases like Japanese encephalitis to the table. Each one is a specialist in its own deadly game.
So how does the crime actually go down? Let's use dengue as our case study here. It all starts with one bite from an infected mosquito. That's it. That person gets sick, and then another totally clean mosquito comes along, bites them, and picks up the virus. The virus then hangs out and multiplies inside that new mosquito for about a week, and then, boom, it's ready to infect the next person it bites. It's just a relentless and incredibly efficient cycle.
But here's the thing, mosquitoes don't operate alone. They're part of a much bigger criminal underworld. So now we're going to expand our investigation to bring in some of their most dangerous accomplices.
And wow, what a lineup it is. I mean, look at this rogues gallery. We've got fleas, the notorious vectors of the bubonic plague. We've got ticks carrying Lyme disease, the tsetse fly, which carries African sleeping sickness. Then there's lice, sandflies, even the so-called kissing bug, which gives people Chagas disease. Every single member of this crew has its own nasty specialty.
So the big question is, how are they so good at what they do? I mean, what makes them so effective? Well, to answer that, we've got to pop the hood and look at their biological toolkit, the anatomy and life cycles they perfected over millions of years, all geared towards survival, which for us often means spreading disease. A lot of it starts right at the mouth. You see, some insects, like cockroaches, just have simple chewing parts for solid food. But our vectors, oh, they have something way more advanced, piercing and sucking mouth parts. A mosquito's proboscis isn't just a simple straw. It's this incredibly sophisticated bundle of sharp little daggers or stylets designed to slip into your skin without you even noticing to get to your blood. It's the perfect tool for exchanging a little saliva and a whole lot of disease.
Their life cycles are also a huge part of their strategy. Some, like lice, go through what's called incomplete metamorphosis. The babies, or nymphs, just look like tiny little versions of the adults. But a lot of our most dangerous criminals, mosquitoes, flies, fleas, they use complete metamorphosis. That 4-stage process with a completely different larval and pupal stage lets them live in totally different environments. The larvae live in water, the adults fly in the air. This makes them incredibly resilient and really, really hard to control.
And all of this explains the different ways they pass germs around. Sometimes it's just mechanical. You know, a housefly lands on something nasty, then lands on your sandwich. Simple, passive transfer. But the really scary method is biological transmission. This is where the pathogen gets inside the insect and actually develops or multiplies. It turns the insect into a living, breathing factory for the disease. And in some cases, the insect can even pass the infection down to its own children. Just think about that, a whole new generation of tiny assassins, born already infected.
So, we've built a pretty solid case against these guys, right? But the story doesn't quite end there. As we start to close our investigation, we find that the relationship between these creatures and us is way more complex than you'd think. They are not just one-dimensional villains. Their role in our world is, well, it's surprisingly complex.
I mean, even if they're not carrying a deadly disease, these creatures can still mess us up directly. We've all felt the sharp pain from a wasp sting or maybe a spider bite, but some of them literally invade our bodies. Think of scabies, caused by mites burrowing into your skin, or a horrifying thing called meiosis, where fly larvae actually grow inside living tissue. And of course, there's just the sheer, maddening annoyance of biting flies and bedbugs.
But now, here is the final twist in the case. The very same groups of animals we've been putting on trial have these unexpected, even beneficial roles. Forensic entomologists use the insects they find on dead bodies to help pinpoint the time of death, literally helping to solve crimes. In medicine, doctors use sterile, lab-grown maggots to clean out wounds that just won't heal. And all around the world, insects are a critical and sustainable source of protein for millions of people.
So where does that leave us? They're vectors for our worst diseases, but they're also helpers in medicine and justice. They're pests and they're protein. They are, without a doubt, the most dangerous animals in the world. And yet, they might also be some of the most important animals that we constantly ignore. What does it mean to share a planet with a creature that is both our greatest threat and, maybe, a part of our solution? That's something worth thinking about.